Hello everybody. Today we're going to be looking at how do you name an organic compound. In order to do this process, you have to have a couple things handy. You have to have reference tables P and Q and reference table R handy. I've also provided notes on how to do this, and if you have your notes open while you're trying this process, you'll be able to follow how to name an organic compound. Has a certain stepwise method that if you follow this method, it will work tried and true for you all the time. Well, first off, I wanted to point out what is the purpose of each reference table. So to start off, I wanted to point out that this reference table right here, reference table P, is useful in counting carbons. That's all it's for. So for instance, if I have 7 carbons in my main chain, I go to 7 right here, and it gives me a prefix hept. The reference table right below it, reference table Q, indicates to me that if there is a single linkage between the carbons, and I'm going to demonstrate how do I know that this has a single link. Right there is a single linkage between them. In here there is a double linkage, and in here there's a triple linkage. When you have a single linkage between the carbons, they're trying to demonstrate to you that you put a suffix on that, for instance, hept 7 carbon chain that I had before. If it was all single linkages, I'd label it ane. So it would be a heptane. If there was a double linkage between the carbons anywhere in that chain, that changes it from a heptane to a heptene. A double bond's kind of a weird thing. So whenever you see something like that, you'll notice that strange things always get a number. So depending on where that linkage is, that double linkage, you'd have to name it, like for instance, 1 heptene, which indicates it's coming, the double bond is between the first and the second carbons. We always try to number things in the lowest possible scheme as possible, so if it's the double linkage is between the first two, we go with the lower of the two numbers. If you had a 3 heptene, that would indicate to you that the double bond is between the third carbon and the fourth carbon in the chain. So that's how you handle double linkages. There should only be one in the chain. Later on in our discussions, we will handle how you have multiples of these. Last but not least, on the bottom of our reference table Q, you'll see it ends with Y and E if it has a triple linkage. So if you notice in our examples here, we have an ethane, an ethene, and an ethine. The reason they used eth as a prefix in the name all the way down here is because there's only 2 carbons in each example. 2 carbons, remember, is right up here on table P. Table P, if you have 2 carbons, you start it with the prefix eth. When you have a double bond, you call it ethene. Now you might notice that they didn't use a number on ethene, because when there's only 2 carbons, it forces it to go off the first carbon, because between carbons 1 and 2, it's an automatic. It's only when you get larger chains that you have to use the numbering sequence, because as you remember, ones in chemistry are redundant. Something else I wanted to point out to you is when you're looking at carbon chains, a lot of times they give you a simplified showing. If you take a look with my diagram up here that I'm about to point an arrow to, you'll notice that I have a bunch of carbons, and in green I have put hydrogens. Since there is so many hydrogens on this drawing, a lot of times people simplify them and they just get rid of all of the hydrogens and just leave an empty stick. An empty stick signifies to us that these are hydrogens. So I'm erasing these right now as I'm doing this for you, and I hope that I don't erase the rest of the carbons that are here. Let me put back any empty sticks that we needed. And now today I'd like to do that also on this one as well, because this is a shorthand convention so that we don't have to put all the hydrogen in. And you guys can do the same when you're drawing organic compounds. You don't have to put the hydrogens in on a carbon-hydrogen. You do have to put them in on an oxygen-hydrogen linkage. But remember, carbon-hydrogen is so commonplace that an empty stick automatically signifies that you have a carbon-hydrogen linkage. All right, so now we're going to get into naming. If you take a look at my list of directions for you, naming organic compounds, the first thing you want to do is find the longest carbon chain. And when you do that, you have to, I'm going up here with this one that we have that I just erased the arrow on. I'm going to get my yellow highlighter out, and I'm going to take a look and see where the longest chain is. Well, this right here would be my longest chain. All right. If I count how many carbons there are in that, there's 1, 2, 3, 4, 5, 6. Now, let's say I didn't go with that and I decided to do this as my longest chain. Well, if I count this direction, this like L laying on its back, it's 1, 2, 3, 4, 5. The goal of finding the longest chain is to actually simplify the work for you. So I need to get rid of that right there. I'm going to get rid of that, and I'm going to replace that. Put that back, carbon back in there, and I'm going to go back to my original plan of having this as my main chain. That's my main chain, and hanging off the side here that I'm going to highlight in blue is a 1 carbon branch. So the first thing I always do is I try to name the main chain and then work off that. All right, so if I count 1, 2, 3, 4, 5, 6 carbons, and I'm going down to my reference table here below, 6 is not hept. I'm going to go ahead and look at my reference table. 6 is hex. Now, if you notice, the linkages are all single bonds, which brings me down to table Q. If I take a look at table Q, down below, if I can scroll up, if I have single linkages, that would end with an ANE. So I'm going to call it hexane. And notice I don't have any numbers. Well, I didn't number the chain yet because all I wanted to do was make sure I knew what the longest chain was. Now, if I take a look at this chain, I notice that the action right here is on the right side of the chain. So I'm going to number this chain 1, 2, 3, 4, 5, 6. The number that I'm about to place down on this paper indicates where this 1 carbon branch is. So, if I want to see what a 1 carbon branch is, down below, this is how you handle a branch. A branch is a meth. But it's not methane. When you have a carbon branch, you add a YL suffix. So methyl means that I have a 1 carbon branch hanging off a 6 carbon main chain. Where is that hanging off of? It's hanging off carbon number 3. 3-methylhexane would be the name of this compound. All right, now moving on to the next one. If I take a look at my next one here, I could say, all right, well, that's it. That's my longest chain. No, it's not. Actually, that's your longest chain. It's 4 carbons long. And once again, I have to realize that this carbon right here and this carbon right here are not connected to each other. Remember, that is a carbon-hydrogen linkage, that open stick. That is not a linkage to the other carbon. So if I was to unbend this and go straight across, this is what this chain really looks like down below. Taking a look at this chain, by counting how many carbons there are going straight across, it gives me a BUT, which is pronunciated bute, and since it's single linkages, the suffix is going to be -ane. I don't need a number on this because this is just nothing more than a straight chain. All right, I just had to be able to see that. Going to my next drawing that's right beside it, if I take a look, this is actually going to be the longest chain that I have here. The next thing I'm going to do is I'm going to circle all my attachments hanging off, and there it is right there. And now I'm going to name my main chain that I've drawn in yellow. I have 1, 2, 3, 4, 5, 6, 7, 8. I'm going to 8 right here to figure out what 8 is. 8 is an oct. Since I have single linkages between the carbons, I'm going to name that ane. That's my main chain. The nice thing about having an ane ending is you don't need any numbers before the name of the main chain. If you had an een or an ein, that's where you have to signify where is the double or the triple bond. But we don't have to worry about that. Now, when I go ahead and look at this chain that's here, I notice that if I drew a line to kind of split this chain right down the middle, I notice that the action is on the right-hand side. So I'm going to number this chain starting here, 1 from end to end, 2, 3, 4, 5, 6, 7, and 8. There's my oct, and the single linkages gives me the ane. Where is the methyl group hiding? Well, remember, one carbon is a meth. A YL indicates that it is a branch. That right there indicates it's a branch. That indicates it's a main chain. So remember, branches come off the trunk of the tree. The trunk of the tree is the main chain. So you have to really train your eye for what is the main chain. So notice what I'm doing with my highlighter. And where is the methyl group hiding? It's hiding off of number 3. So 3-methyl octane. All right. I'm going to go up to the top now, and I'm going to show you how I'm going to do these next set a little bit quicker. Hopefully we can see these. We're going to take a look now at some other versions. Just going to try to get a main chain here. Main chain right there. Main chain right there. Notice I'm only looking at the linkages of carbons. I'm kind of factoring out all the hydrogens that are there. Oop. Let me get rid of that little blip there and draw that so we can just only see carbons linked together. These are my main chains, guys. All right, this is what we're doing. Main chains only. See how I got all the carbons in there? Now, I'm circling anything that's weird. So that's not a carbon-hydrogen linkage. That has a carbon in it. That right there. That right there. So notice it's kind of like we're going hunting. We're hunting rabbits. All right. And as you can see, these are issues that I have to address when I'm going to name this. 4-carbon main chain, that's butane. I have off carbon number 2, I have a methyl. So that's why the first one I have here is a 2-methyl butane. In the next problem, I have a 1, 2, 3, 4, 5. Okay, so that's a pent. Single linkages between them makes it an ane. I have a 1-carbon branch off the 1, 2, 3, 4, 5. It doesn't matter which way you number this because it's smack dab in the middle. That's going to be a 3-methyl pentane. On this one, I notice the action's towards the left, so I'm going to number this one. 1, 2, 3, 4, 5, 6. That's 7. 1, 2, 3, 4, 5, 6, 7. That is a heptane. I gotta have to really indicate that that is A and E on there. You got to make sure that you write it clearly, because sometimes us teachers can't really see that we're getting old. All right, so this is a 2-methyl heptane. All right, that's how you handle that one. The next one that we have here is 1, 2, 3, 4, 5, 6, 7. That is also a heptane. Notice I have a branch here and a branch here, 2 different positions of branches that are both 1 carbon in length. This would be a 2, 4. Now, instead of saying methyl, methyl, I'm going to say how you say 2 of them, dimethyl. Now, how could this be an ethyl? Well, this would only be an ethyl if you had a situation, I'm going to erase this word right here just so that I have a spot to draw this in, just to show you the difference between a methyl and an ethyl. If you had your 7-carbon chain, 1, 2, 3, 4, 5, 6, 7, this is an example of an ethyl. So if you look right there, that right there is the ethyl group hanging off the main chain, hept. So there's the heptane, and that right there is my ethyl. And that's coming off carbon 1, 2, 3, 4. So that's the difference between an ethyl and right here, a dimethyl. All right, now going to our last problem that's on here. I have 1, 2, well, this is my main chain, so that's not a branch. Okay, hold on a second, I need to get rid of you. There we go. We're going to get rid of this because that's part of the main chain. I almost fell for it. That right there are all the carbons. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a decane. And just 1 carbon. So by encasing all those in the main chain, I've made my life a lot easier. And all I have is a methyl hanging off of the carbon on this side. So 1, 2, 3, 4, 5. So it's 5-methyl decane. Okay, guys. So hopefully that was helpful in helping you name organic compounds.